Good afternoon, students. Welcome back to the chapter Quadrilaterals. So today we shall discuss some problems, proof and problems. Okay. So first one, ABCD is a parallelogram in which P and Q are midpoints of opposite sides AB and CD given in the figure. If AQ intersects DP at S and BQ intersects CP at R, show that APCQ is a parallelogram. Second one, DPBQ is a parallelogram and PSQR is a parallelogram. So we have to prove that these three are parallelograms. Okay. So given ABCD is a parallelogram and P and Q are the midpoints of AB and CD respectively. Okay. So P and Q are the midpoints of AB and CD respectively. To prove that APCQ is a parallelogram. So proof, since ABCD is a parallelogram, then AB will be parallel to CD. Okay. So this implies AP is parallel to QC because parts of a parallel line are parallel. Okay. So AP is a part of AB and CQ is a part of CD. Then we can write AP parallel to QC or CQ. Now we know AP is equals to half AB because P is the midpoint and CQ is equals to half CD. Q is the midpoint of CD. Therefore, we can write AB is equals to CD because opposite sides of parallelogram. We know AB equals CD, opposite sides of parallelogram. Then we can write half AB equals half CD, AP equals CQ. Because half AB is what here? Half AB is AP. Half CD is what? CQ. Therefore, we can write AP equals CQ. So, from 1 and 2, AP is parallel to QC and AP is equal to QC or CQ. From 1 and 2, we can write APCQ is a parallelogram. Again, I will tell you, see, we have to consider, we have to show APCQ is a parallelogram. Since AB is parallel to CD, because ABCD is a parallelogram. AB is parallel to CD. Then AP is parallel to QC or CQ because parts of a parallel line are always parallel. Okay. Then we can write AP is equals to half AB. Why we can write AP equals half AB? Because P is the midpoint of AB. And we can write CQ is equals to half CD because Q is the midpoint of CD. Given. Therefore, we can write, and we know AB is equals to what? CD because opposite sides of a parallelogram are equal. Then we can write AB is equals to, that is half AB is equals to half CD we can write. Okay, half AB equals half CD we can write and AP is equals to CQ. So from 1 and 2 we can write APCQ is a parallelogram. Okay, so here like this we have to prove that APCQ is a parallelogram. Okay, so here you have to keep in mind 2 points. If P is the midpoint of AB, then we can write AB equals half AB. And Q is the midpoint of CD, then we can write QC is equals to half CD. That too you have to keep in mind. Then, since half AB is equals to half CD, we can write AP equals CQ. So, from 1 and 2, we can write APCQ is a parallelogram. Okay, so this is how we proved that APCQ is a parallelogram. Next, we have to prove DPBQ is a parallelogram and PSQR is also a parallelogram. In the same way, how we have proved APCQ is a parallelogram, in the same way we can prove DPBQ is a parallelogram and PSQR is also a parallelogram. Okay, we will see how we have to prove that one. Okay, so now consider next one to prove DPBQ a parallelogram. Okay, so here AB is parallel to CD. This implies PB is also parallel to DQ. I told you parts of parallel lines are parallel. Now we can write half AB is equals to half CD. So half AB can be written as PB, half CD can be written as DQ. So from 3 and 4 we can write DPBQ is a parallelogram. Okay, so again I will tell you AB is parallel to CD implies PB is parallel to DQ because parallel parts of a parallel line are parallel. Okay, then we can write PB as half AB. We can write DQ as half CD. That means half AB can be written as what? PB. Half CD can be written as what? DQ. So from 3 and 4, since PB is parallel to DQ and PB is equals to DQ, then we can write DPPQ is a parallelogram because opposite sides are parallel and opposite sides are equal. Then we can write it as a parallelogram. Okay. Now, after this, we can prove that PSQR is also a parallelogram because now we have proved DPPQ is what? A parallelogram, isn't it? Since DPBQ is a parallelogram, we can write DP parallel to QB. Okay, so we can write DP parallel to QB. If DP is parallel to QB, we can write SP parallel to QR because parts of a parallel are parallel. Then we can write PSQR is a parallelogram. Okay, so this is how we can prove that APCQ, DPPQ and PSQR are parallelograms. Okay, so next problem. The angles of a quadrilateral are in the ratio 3:5:9:13. Find all the angles of the quadrilateral. Okay, so here they are given the angles of a quadrilateral are in the ratio 3:5:9:13. Now let us consider the angles of the ratio as 3:5:9:13 given. Let these angles be A, B, C and D. Now we can write A is equals to 3x, B is equals to 5x, C is equals to 9x, D is equals to 13x. Okay, because the ratio they are given 3:5:9:13. Okay, then ABCD we are considering ABCD as angles means then A will be 3 times x, B is 5 times x, C is 9 times x, D is equals to 13 times x. Now we know the sum angle property of a quadrilateral. All the angles of a quadrilateral, is equal to 360 degrees. Okay, we know in a triangle if you take all the angles are equal to 180 degrees. In a quadrilateral if you take all the angles are equal to 360 degrees, whether it may be a square or a rectangle or a rhombus or any four-sided geometrical figure. Okay, so the angles will be equal to 360 degrees. Now A plus B plus C plus D is equals to 360 degrees, 360 degrees because angle sum property. Now you substitute value of A 3x, value of B 5x, value of C 9x and value of D 13x. So we can write 3x plus 5x plus 9x plus 13x equals 360 degrees. So if you add 30x is equals to 360, x will be equal to 360 degrees plus 30 degrees. Now if you simplify, x will be equal to 12 degrees. Okay, therefore we can write the angles are A is equals to 3 into x, 3 into 12 degrees. 3 12 is the 36. Angle B is equals to 5x, 5 into 12 degrees, that is equals to 60 degrees. 12 5 is 60. Angle C is equals to 9 into x, 9 into 12, that is equals to 108 degrees. And angle D is equals to 13x, which is equals to 13 into 12 degrees, that is equals to 156 degrees. So like that we can find the angles of a quadrilateral if they are given a ratio. Okay, if they are given the ratio, then we can find the angles of the quadrilateral. Okay, so now like that I will give some other ratio means you should be able to find the angles of the quadrilateral. Okay, so I have given two problems, you solve that one. Okay, so if I have asked first one, PQRS is a parallelogram in which A and B are the midpoints, and respectively prove that PBR is a parallelogram. You can prove it. Okay, so try that and solve it. I think you understood in this class. Thank you.